Welcome back to the deep dive. Today we're tackling the architecture of modern video distribution.
Right, the actual physical infrastructure behind the screens.
Exactly. We've pulled some technical specs and data sheets from HDTV Supply today to answer a really specific engineering challenge for you.
A very common one, though.
Yeah, how do you move broadcast quality 4K video across a massive building without losing data? Or, running into those awful length limitations.
Which is where our case study comes in. The Zenty ZT-333-IP400 decoder?
Quite a name.
It is, but it's a really fascinating piece of hardware because it represents this major shift in philosophy. We're moving away from dedicated video cabling entirely.
Right, treating video just like any other type of data on the network.
Exactly.
Which is the whole AV over IP concept. So instead of a fragile HDMI signal effectively dying after, 50 feet?
Give or take.
We are leveraging the backbone that is already in every commercial building, gigabit Ethernet.
Which fundamentally changes the physics of the installation. I mean, when you plug a standard HDMI cable in, you're sending a raw electrical signal.
Just straight pipe.
Right. But with the Zenty ZT-333, you are packetizing that video. You're chopping it up into little data packets, just like an email or a web page, and shooting it through a standard network switch.
And looking at the specs for this thing, the Zenty ZT-333-IP400 4K, 60 Hz, 4.4.4, that 4.4.4 part jumps out immediately.
Oh yeah, the chroma subsampling.
Right. It suggests this decoder isn't tossing out color data to save bandwidth.
And that is the key differentiator here. Most streaming services, and even a lot of hardware extenders out there, they compress video to 4.2.0.
Right.
They strip out color information because the human eye is pretty forgiving with moving images.
Yeah.
But the Zenty keeps every single bit of that color data intact.
Which is basically non-negotiable if you are in a field where detail is everything. I'm thinking of, say, radiologists looking at x-rays for you, or graphic designers.
Or even just a high-end home theater where you want the image to look exactly like the source material.
Yeah. Precisely. It also supports HDR10 in pass-through mode, plus Dolby Vision. So it ensures that the dynamic range, the contrast, and the color depth actually matches that high pixel count.
You aren't just getting the resolution, you are getting the total fidelity.
Exactly.
Now, the infrastructure requirement here is surprisingly accessible. We aren't running fiber optics or some proprietary copper.
No, this runs on standard Cat5e.
Just twisted pair.
Yeah, standard twisted pair. And because it's just data on a network, you can transmit that signal up to 330 feet. That's 100 meters straight from the switch.
That distance is massive. 330 feet effectively covers the footprint of most commercial floors.
You're completely untethered from the server room.
Which leads right into the scalability aspect. Since we're on a network now, we aren't limited to just point-to-point connections.
Right, you can create a massive matrix. The specs actually indicate support for video walls up to 16 by 16 screens.
That is a 256 screen array.
It's huge. But for me, the interesting part isn't just the sheer number of screens, it's the flexibility. Because it's IP-based, those screens don't have to be hardwired into a permanent physical grid, do they?
Not at all. You are essentially turning the building's existing Ethernet wiring into a fully programmable video canvas.
Wow.
You can route any source to literally any screen. And with the KVM feature, the keyboard video mouse integration, you get this roaming USD extension.
Oh, this actually solves that huge acoustic problem in post-production suites.
Yes.
You can finally rack mount all the noisy hot computer hardware in a closet down the hall and keep your creative desk completely silent.
Without the input lag you'd usually get from cheap extenders. It separates the user from the machine entirely.
Now, usually, this is exactly where the trade-off happens. You push that many pixels down a long pipe, and the bandwidth for the audio gets strangled. Is the Zenty compressing the soundstage to make room for all that 4K video?
Surprisingly, no. The datasheet shows full support for up to 7.1 audio channels. Yeah, including Dolby Atmos and DTS:X. The audio remains entirely uncompressed. Since it's all packetized data, the network switch just handles the traffic without prioritizing the video over the audio in a destructive way.
But the complexity usually spikes right around here. If it's all IP-based, does this require a network engineer to configure the routing tables, or is the control layer actually user-friendly?
It seems perfectly designed to bridge that gap. They offer a Windows PC configurator, an iPad app called ZNet, plus a dedicated IP controller.
So you don't need to be typing command line code just to switch your inputs.
Definitely not.
It reads like serious professional grade gear. especially seeing that HDTV Supply backs it with a 5-year Zenty warranty and US-based support.
And that reliability factor is huge when you are installing this in a client's business. Stability really is the currency of professional AV. You need to know the handshake between the source and the display is going to happen every single time you turn it on.
So you basically have a device that takes the highest possible quality video, treats it like everyday internet traffic, and lets you send it anywhere in a building with zero loss.
It bridges the gap between IT and AV beautifully. It makes high-end distribution scalable in a way that traditional cabling just can't match.
It really makes me wonder about the future of the cable industry as a whole.
Oh, for sure.
With AV over IP becoming this robust and this accessible, are we actually witnessing the slow death of the traditional HDMI cable, at least for anything other than a simple desktop patch cord?
As network speeds keep increasing and the costs come down, the days of running dedicated copper video cables through walls are definitely numbered.
A fascinating shift in how we think about connectivity. Definitely something for you to consider the next time you are planning a setup. That is it for this deep dive.